Hello, in this video we will talk about the uncertainty principle. The uncertainty principle is the fundamental concept in quantum mechanics. It states that there is a limit to a precision with which certain pair of physical properties such as momentum and position can be simultaneously known. In other words, if more accurately one property is measured, the less accurately other property can be known. If we combine the different frequency value, then where does the peak line up? It makes a bigger value, but in some place it can sell out. If we combine the same frequency value, then they will make a clear wavelength and has a higher amplitude. And this is the quantum object with wave and particle nature. It will lose certainty with both momentum and position to accomplish this, because the position could be somewhere in the wavelength. If many waves are combined, the momentum uncertainty is smaller and the position uncertainty is bigger. If a few waves are combined, the momentum uncertainty is bigger and the position uncertainty is smaller. So the particle has the uncertainty property because of the superposition state. And superposition has been found by many scientists and experiments. According to Max Planck and two-slit experiment, photon move as a wave because it split electromagnetic wave while moving, and it split as many small waves through the narrow slit. So the photon has the wave property. And according to the photoelectric effect, the high energy photon can knock or eject the electron as a particle. So the photon has the particle property. And according to the Schrödinger cat thought experiment, the particle that has the superposition state can simultaneously change to particle or wave. As the result, the photon has the superposition state because it can change to wave or particle simultaneously. For this, I have two questions. Suppose the high energy photon is in a superposition state, so we have those states all along. And why doesn't the low energy photon have the particle property? At this point, I will explain the property of photon in another way. The light or photon is the electromagnetic radiation when it left the sun, because the sun has enormous energy from the nuclear fusion. And the photon can carry momentum and has the high electromagnetic radiant energy. If the photon is left from low energy source, it will only have the wave property because it doesn't have enough energy and electromagnetic wave to form as a particle. And the high energy photon can carry momentum and has the particle property because it is a sphere of high energy and strong electromagnetic wave. And the sphere is from the combination of many electromagnetic waves. If we release the high energy photon to propagate, it will lose energy while moving by spreading the energy within the electromagnetic wave little by little. And lastly, the remaining is the lower frequency wave. At this state, the photon can change back to particle by itself. We can know this by letting the high energy photon or light move through a very long glass tube, and then it will lose energy while moving. And lastly, it will lose the particle property by spreading out energy within the electromagnetic wave. Or we can release the high energy photon within the round glass tube, and then it will spread out the energy and electromagnetic wave in the tube while moving or bouncing in the tube. In the two-slit experiment, if we set the experiment in the dark room and has the high energy light beam, the observer can see the photon reach the wall because it is spreading the well since it starts to move until it reaches the wall. So the photon doesn't become the well when it goes to the narrow slit. It splits the well since it starts to move. As a result, the superposition of photon doesn't apply all the time. It will appear when the photon has the high energy. Otherwise, the photon has only the well property. Furthermore, the high energy photon can change from particle or well simultaneously. It only splits the electromagnetic well while moving, until the state that it only has the well property and doesn't have the particle property anymore. I think if we found a proper solution for the mystery of superposition, it wouldn't make the quantum mechanics too complicated to understand. Also, Max Planck and Albert Einstein weren't satisfied with the result of quantum mechanics. If you have any question or see something wrong in this video, please comment below. I will try to find answer and make correction for this. If you see the video is useful, please help to share this video and subscribe to get another video. Thanks.